Welcome to my YouTube channel Knowledge Entertainment, and now we'll do some more questions on complex numbers. This is another lecture in this series of complex numbers and quadratic equations. So let us start with some more questions today. So the first question which I'm going to solve today is find least value of n such that 1 plus iota over 1 minus iota raised to the power n is equal to its reciprocal 1 minus iota upon 1 plus iota. So this is our first question today. So how to solve it? One thing is to be noted that we have to find the least value of n satisfying this equation. Now what I'll start this question with, this term on the right hand side, if I take this into the left hand side, the denominator will become the numerator and the numerator will become the denominator. So what you will get in the next step 1 plus iota over 1 minus iota, this one multiplied by this one, 1 plus iota over 1 minus iota raised to the power n is equal to 1. This 1 plus iota has become the numerator here, and this 1 minus iota has become the denominator here. Now these two are the same terms. The only difference is the power. The power is 1 here and the powers are n here. So when they will be multiplied, the powers will be added. So in the next step, you will get 1 plus iota over 1 minus iota raised to the power n plus 1 is equal to 1. Now why I have left this space? Because I want to rationalize this one. I am multiplying this by 1 plus iota over 1 plus iota. So what you will get in the next step, you will get square of 1 plus iota, that means 1 plus iota square plus 2 iota, and in the denominator this is 1 minus iota into 1 plus iota, that means a minus b into a plus b, which means a square minus b square. So it is 1 square minus iota square is equal to 1. So what you will get then? This 1 and this iota square is equal to minus 1. So 1 and minus 1 will be cancelled out. In the denominator it is 1 and minus iota square means plus 1. So 1 plus 1 is 2. 2 iota upon 2. 2 iota upon 2. 2 will be cancelled out. You will get iota raised to the power n plus 1 is equal to 1. So in the next step, what you have to do, iota, I am writing it as iota square raised to the power n plus 1 by 2. The powers I have multiplied by 2, I have divided by 2 is equal to 1. And this iota square is now equal to minus 1. So minus 1 raised to the power n plus 1 by 2 is equal to 1. Now, which least power to the minus 1 is equal to 1? Everybody know that it is 2. Because minus 1 raised to the power 1 is minus 1. And minus 1 raised to the power 2 will become equal to 1. So the least value of n we will get if we will equate this power to the 2. So for this equation to be true and n to be least, what we should have n plus 1 upon 2 equal to 2, and this will give you n is equal to 3. So the least value of n is 3, which will make this equation correct. So this was the first question. Now I'll move on to the next question. So in the next question, the question is find the locus of z such that mod of z minus 5 iota over z plus 5 iota is equal to 1. We have to find the locus of z, that means x plus iota y, or you can say in coordinate geometry the ordered pair x, y, that means the first coordinate is x and the second coordinate is y. So how to do this? for solution, take one of the terms from the denominator to the right hand side by multiplication. You will get mod of z minus 5 iota is equal to mod of z plus 5 iota. And what is z? Z is a complex number. So we can take z as x plus iota y. So this, what is the next step I'm going to take is I'm replacing this z by x plus iota y. X plus iota y minus 5 iota is equal to x plus iota y plus 5 iota. Now, the only real term in this complex number is x, and the imaginary one is y minus 5. So I can write it as x plus iota y minus 5 is equal to, on the other side it is x is the real part and imaginary part is y plus 5. Better to take square on both sides so that to get rid of the square root for the modulus value. And now, what is the square of the modulus of this complex number? It is real part square plus imaginary part square. That means x square plus y minus 5 square is equal to, similarly on the other side is x square plus y plus 5 square. X square is cancelled. You will left with y plus 5 square minus y minus 5 square is equal to 0. And we know that a plus b whole square minus a minus b whole square is equal to 4ab. So what you will get from here is 4 into 5 into y is equal to 0. This means y is equal to 0. And y is equal to 0 is the equation of x-axis. That means the locus of z satisfying this equation is x-axis. The point must lie on x-axis if this equation is to be satisfied. So it was the second question of the day, and now I'll move ahead slowly and slowly. I promised you that I'll move on to the difficult, tricky questions, and that's what I'm going to do slowly and slowly. The next question is solve the equation. I'm going to write an equation of power 4 in z. So the equation is 2z power 4 minus 14z cube plus 33z square minus 26z plus 10 is equal to 0, given one root is 3 plus iota. One root of this equation is given to us, and we have to find the other 3 roots. The equation is in power 4, so it must have 4 roots. One of the roots is given, the 3 other roots we have to find. One thing is to be noted that all the coefficients, that is 2, minus 14, 33, minus 26 and 10, all the coefficients are real. And if the coefficients are real, then every polynomial, if it has complex roots, then these complex roots must occur in conjugate pairs. So that means here the coefficients are real. So if one root is 3 plus iota, 3 minus iota must also be a root of this equation. So that means we know 2 roots now. So for solution, since 3 plus iota is a root of given polynomial equation with real coefficients, 3 minus iota must also be a root. 3 minus iota must also be a root. So that means now we know 2 roots. That means we know a factor of degree 2 of the given equation. So this means z minus 3 plus iota into z minus 3 minus iota is a factor of given polynomial equation. And now what it is? Just we are going to multiply these two to find the exact factor, and this is now, you can write it as z minus 3 minus iota into z minus 3 plus iota. So it is a minus b into a plus b, and a minus b into a plus b, you know, is a square minus b square. So it is z minus 3 whole square minus iota square, and z minus 3 square is z square minus 6z plus 9, and minus iota square is plus 1. So that means z square minus 6z plus 10 is a factor. So one factor successfully we have obtained for the given polynomial equation. For the other factor, what we are to do? We are to do the left hand side of this polynomial equation by the factor z square minus 6z plus 10, and we will find the other factor. So now we are going to divide the left hand side of the given polynomial equation, where the right hand side is 0, with the factor that is z square minus 6z plus 10. So it is 2z4 minus 14z cube plus 33z square minus 26z plus 10, and I am going to divide it by z square minus 6z plus 10. So when dividing, first you are having z square and you want 2z4, so you will have to multiply by 2z square and you will get 2z power 4. This multiplied by minus 6z will give minus 12z cube, and this multiplied by plus 10 will give 20z square. Changing the sign and adding, this will be cancelled out. Minus 14z cube plus 12z cube will become minus 2z cube. 33z square minus 20z square will become 13z square. Now minus 26z and plus 10 were already there. Your leading term is z square, and now you want minus 2z cube, so you will have to multiply by minus 2z. So minus 2z into z square is minus 2z cube. Minus 2z into minus 6z is plus 12z square, and minus 2z into 10 is minus 20z. And once again, changing the signs and adding, this will be cancelled. Here you will get z square, here you will get minus 6z and plus 10. And this term is same as your this z square minus 6z plus 10. Now what you have to do? Just to multiply by 1. You will get z square minus 6z plus 10, and changing sign and adding, all the terms will be cancelled, giving no remainder. That means the factor was exact, and it was because the factor was made by the roots, two roots of the given equation. Now the given equation can be written as, your given equation was this. Now you know both the factors. One of the factors was z square minus 6z plus 10, and this will give you two roots, 3 plus iota and 3 minus iota. The other factor is here, that is your quotient 2z square minus 2z plus 1 is equal to 0. And now product of two numbers is 0 if and only if one of them is 0, either this is 0 or this is 0. So z square minus 6z plus 10 is equal to 0, or 2z square minus 2z plus 1 is equal to 0. If this is equal to 0, you know what the roots are. The roots are simply 3 plus minus iota, and this is a quadratic equation in z. So roots can be obtained by solving it using your formula minus b plus minus under root b square minus 4ac upon 2a. So use the formula. So it is 2 plus minus square root b square is 4 minus 4ac. 4 into 2 into 1 is 8 upon 2 into 2 is 4. So you get 3 plus minus iota and 2 plus minus, this is under root minus 4, and under root minus 4 is 2 iota divided by 4. So what the four roots are now? these are 3 plus minus iota, and 1 by 2, 1 plus minus iota. So these are the 4 roots of the given polynomial equation which we were to obtain. Now I'll move on to another question. So there are several questions on complex numbers. So a lot of practice is needed, and that's what I'm going to do. I'm going to give you more and more practice on complex numbers to make you handy with more tricky and typical questions. So the next question what I'm going to solve is solve for z. Solve for z, and the equation is 1 upon z plus 1 upon 1 plus 2 iota is equal to 1. We have to solve this equation to obtain the complex number z, and the solution is very easy once again. So solution is very easy. As I told you, it is 1 upon z is equal to, take this term to the other side, it is 1 minus 1 upon 1 plus 2 iota. So 1 upon z is equal to, take out 1 plus 2 iota LCM. So it is 1 plus 2 iota minus 1 is cancelled. So you get 2 iota upon 1 plus 2 iota. And now multiply the numerator and denominator both by 1 minus 2 iota. So what you will get? You will get 1 upon z is equal to, in the numerator you will get 2 iota minus 2 iota into 2 iota will become 4 iota square, and divided by, this is a plus b into a minus b. So 1 square minus 4 iota square. 1 square minus 4 iota square. So now it is 2 iota. Since iota square is equal to minus 1, so minus 4 into minus 1 will become plus 4. And in the denominator it is 1 square is 1 and iota square is minus 1, so the second term will become plus 4. So 1 plus 4 is equal to 5. And now it is the value of 1 upon z. But what you want z, so take reciprocal on both sides. So your z is 5 upon 2, 4 plus 2 iota, you can write it like this. And once again multiply the numerator and denominator by 4 minus 2 iota to find the exact real parts and imaginary parts of z. So what you will get? This is 5 into 4 minus 2 iota, and in the denominator once again you are having a plus b into a minus b. So once again it is a square plus b square, and a square is 4 square is 16 minus b square is 2 iota square, so it is 4 iota square. But iota square is once again minus 1, so minus 1 into minus 4 will become 4, 16 plus 4 will become 20. So you will have 5, 4 minus 2 iota and divided by 20. This 20 will be cancelled by 5 to give you 4. And now separate real and imaginary parts of this. So what you will get? 4 upon 4, that means 1, minus 2 iota upon 4, that means 1 upon 2 iota. So this is our complex number 1 minus half iota. That is the complex number z that will satisfy our given equation 1 upon z plus 1 upon 1 plus 2 iota is equal to 1. So this was our fourth question of the day, and now I'll move on to the fifth question. Another question for your practice. More and more practice will make you more and more handy over typical questions and tricky questions which will come later on. But before that, a lot of practice is needed. So another question for your practice. Solve for x and y. Solve for x and y. This equation, and the equation is x upon 1 plus iota. This time I am not taking z as a complex number. I am taking x and y separately. So it is x upon 1 plus iota is equal to 1 minus 5 iota over 3 minus 2 iota plus y upon 2 minus iota. This time x and y are being taken separately. But still the question belongs to complex numbers because there are a lot of iotas there. So how to solve this equation now? And there are many methods, many methods. you can first take LCM, then later on rationalize. You can first rationalize and then later on taking LCM. I think first multiply in denominator by 3 plus 2 iota for this term will be the easier way. So what you will get, x upon 1 plus iota. For this term, 1 minus 5 iota upon 3 minus 2 iota. As I told you earlier, multiply the denominator and numerator by 3 plus 2 iota. And the last term I am keeping as it is. So what you will get now, x upon 1 plus iota. The second term will become, in the numerator you will have to multiply these two. So 1 into 3 is 3, 1 into 2 iota is plus 2 iota, minus 5 iota into 3 is minus 15 iota, and minus 5 iota into plus 2 is plus 10. I have directly substituted the value of iota square is equal to minus 1 in this step. And in the denominator you will get a minus b into a plus b, so it will again be a square minus b square. So a square is 3 square is 9, minus b square is 2 iota whole square, that means 4 iota square. Once again iota square is minus 1, so it will become plus 4, plus y upon 2 minus iota. So in the next step you will get x upon 1 plus iota is equal to, here you will get in the numerator this 3 plus 10 is 13, and this 2 iota minus 15 iota is minus 13 iota divided by 13 plus y upon 2 minus iota. And what the way I have chosen was very much correct, because here the 13 is the factor from the numerator, in the denominator as well will be cancelled out. So what you will get in the next step is x upon 1 plus iota, and this term will become 1 minus iota plus y upon 2 minus iota. And now take LCM from the right hand side by taking denominator as 1 for the first term. So you will get x upon 1 plus iota is equal to 2 minus iota is the LCM on the right hand side. You will get 1 minus iota into 2 minus iota here and plus y. So the question is now, I think, more easier as it was looking in the starting stage. So what you will get, x upon 1 plus iota is equal to, now multiply these two, you will get 2 minus iota minus 2 iota, and minus iota square, minus iota into minus iota is minus, plus iota square is once again minus 1, plus y upon 2 minus iota. So final step now, this 1 plus iota I am going to take on the right hand side, and 2 minus iota I am going to take into the numerator of the left hand side. So it is 2 minus iota into x is 1 plus iota into, solving this you will get this 2 minus 1 is 1, this minus iota minus 2 iota is minus 3 iota, and this is y also here. Once again opening the brackets on the right hand side and then comparing real and imaginary parts for both sides, we will get some equations, and solving these we will get the values of x and y. So what you are going to get here is 2x minus iota x. On the other side, this is your real part, this is your imaginary part. This is your real part 1 plus y, and this is your imaginary part minus 3 iota. So 1 into 1 plus y is 1 plus y. I am taking 1 plus y as real part as a whole. Then plus iota into 1 plus y. So plus iota into 1 plus y. Then 1 into minus 3 iota. So minus 3 iota. And plus iota into minus 3 iota is minus 3 iota square, that means plus 3. And now equate real and imaginary parts from both sides. Equating real parts from both sides, the left hand side is having real part as 2x is equal to, on the right hand side you are having 1 plus y, this term, and this 3 also, so plus 3. So you will get an equation. What the equation is, 2x minus y is equal to 4. This is an equation what I have obtained by equating real parts from both sides. And now I am going to equate the imaginary parts. So, and imaginary part on the left hand side is minus x from here, and imaginary parts from the right hand side is 1 plus y from this term and minus 3 from here. So what you are going to get is another equation, and the equation this time is x plus y is equal to 2. So here is the second equation. Now you are having two equations in two variables. So you can simplify it. Just simply add them. Adding them, minus y and plus y will be cancelled. So 2x plus x will become 3x is equal to 6, giving the value of x to be equal to 2. And if you substitute the value of x is equal to 2 here, you will get the value of y to be equal to 0. So this is how to solve a complicated equation in x and y, to find the values of x and y from a complex equation. So here I am going to stop this video. In the next video, we'll solve more and more questions, maybe some tricky questions, maybe some more typical questions on complex numbers and quadratic equations. Till then, enjoy my channel, enjoy knowledge entertainment. Thank you.